Thank you for coming back to watch this video on the common tangents. Common tangents are lines that are tangent to two circles. And if we look down here, here's an example of some common tangents. So there's a common tangent here because this tangent is tangent to both of these circles. This is a common tangent down here. And if I just turn the page for you, we'll come back. Here's another common tangent here. And here's another common tangent, tangent to both circles. This type of tangent that is kind of outside of those two circles, if you will, this is called a common external tangent. Okay? And we can kind of think of this as a belt that fits tightly around two circular pulleys, almost like a bicycle. Here's the small chain, wheel, sprocket, gear, whatever you want to call it, that's by the pedals. And here's the bigger one that's got the bigger gears on it. So, or is it reversed the other way? Oh, I think this one has the pedals on it. I don't remember. It's been a while since I've looked at my bike. I just take it for granted. So, but you can kind of think of this as the bike chain wrapping around here. And we want to find the distance between the centers of the two circles. So let's go ahead and put that on here, what it is that we're trying to find. We're trying to find the distance between the two centers. And that's what we're looking for, that pink one here. That's kind of our X, if you will. So kind of steps to do these. When you do these common tangent problems, the first thing you're going to do is to connect the centers. Okay. The next step that you want to do is we are going to make sure that there are radii drawn to points of tangency on the same common tangent. So we are going to draw radii to the points of tangency on the same tangent. So we have a radius drawn here, but that's drawn to this top tangent. And there's a radius here, but drawn to the bottom one. We need to pick one. Pick one. Let's go with this one down here. So we're going to take the ruler. If you don't have a ruler, please go get one right now. Pause the video and go get one. All right, it's very, very important that this radius that we're drawing is perpendicular to this tangent. So notice I'm lining up my tick marks again to make sure that that radius, which is a length of 3, is perpendicular to that tangent. That's a right angle here. There's also a right angle over here at this radius to that tangent. All right, now, next step is through the center of the smaller circle. You're going to draw a segment that is parallel to the common tangent. All right, again, through the center of the smaller circle, so here's our smaller circle, draw a segment that's parallel to that common tangent. So I'm taking my ruler right here. I'm going to put my ruler right along that common tangent and parallel to that common tangent through the center. So I'm just going to slide it up. Slide it up right there. parallel to the common tangent. It's really important. It's parallel to the common tangent. Not parallel to the line joining the centers, but parallel to that common tangent. Which means if this was a right angle down here and we're going parallel, that's a right angle here, and this is a right angle over there. So your next step is actually to mark all the right angles. Okay, now, when you look at this, you should see a rectangle and a right triangle. Here's another right angle that I want to mark. Make sure you mark that one down there. You see a rectangle here and a right triangle. I want you to go ahead and take a colored pencil and shade in that right triangle. Then we're going to redraw that right triangle down here. Bigger. It's just too skinny and weird shaped in there. So we're going to draw that right triangle down here. Here's the right angle. Okay. Now, if we start transferring some measurements, see this line right here, this green one that was there originally? That's exactly the same length as this external tangent. So this is 15. Look over here. See this segment over here? This radius was a length of 3. Well, on the other side of the rectangle then, this much over here is also 3. That's on the rectangle. This whole radius was 7. That much of it is 3, which means this piece right here is 4, and that's this in our orange triangle down here. Maybe I'll shade this in so you can see that that's the same triangle. Oh, and then our last step, this hypotenuse is exactly what we're looking for. That distance between the centers. We can use Pythagorean theorem, so that's your last bit. Use Pythagorean theorem. To find the necessary measurement. And let's do that. We have 4 squared plus 15 squared equals x squared. That's 16 plus 225 is x squared. 241. So x is plus or minus the square root of 241. Can't be negative. So that distance x is square root of 241 as an exact answer, or 15.524 for an approximation. That's it. There's the distance between the two centers. Oh, and centimeters. Here we go. Okay, turn the page. Let's try another one. On this one, the centers of two circles are 28 centimeters apart. Find the length of the common external tangent. All right, here's our external tangent right now. Let's call that x. That's what we're looking for. And if we follow our steps from the previous page, we're going to connect the centers. Don't have that done yet, so we're going to have to connect the centers. Take your ruler, connect those centers, then draw radii to the points of tangency on the same tangent. Done. Those radii are drawn. Perfect. And next step, through the center of the smaller circle, center of the smaller circle, we want to draw a line or a segment that is parallel to this common tangent. So I'm going to take my ruler, put that along that common tangent, and I'm going to slide it right up, remaining parallel until I hit the center of that smaller circle. Right there. Okay. Mark all the right angles. This radius was perpendicular to a tangent, right angle there, right angle here, right angle there, over there, and one more right there. Okay. Again, you should see a rectangle and a right triangle. Let's go ahead and shade in that right triangle because that's the important piece. When we shade in that right triangle, I'm going to go ahead and redraw that right triangle down here. Okay. All right, some measurements that we need. Where's the x? This x is that common external tangent. Well, that's the same length as what was that green segment up there, which is the bottom of our right triangle. Looking up here, this radius was 8. You can transfer that over here. This little bit in there is 8, which leaves us 12 for that piece. And then the last part, we need this pink up here that joins the centers. Well, what do we know about those centers? They are 28 centimeters apart. So this is 28. I never wrote that in there before, but I can bring that down. That's 28. And now we can use Pythagorean theorem to figure out what that x is. I am going to use some inside numbers because I noticed that 28 and 12 are both divisible by 4, which makes this a 7 and that a 3. And let me call this y then. That means that 3 squared plus 3 squared plus y squared equals 7 squared. 9 plus a y squared is 49. Y squared's 40, which is 2 square root 10 for y. That's the inside number, so we're going to have to multiply back by 4 to get back out here. So x, which is the length of that common external tangent, is 4 times 2 square root 10, or 8 square root 10. That's what we're looking for. All right, now we just did a couple of problems with external tangents. They're kind of on the outside of the circle. Here's one that's called a common internal tangent. You see how it kind of crosses between the two circles instead of being outside of the two circles? This is a common internal tangent right here. Common internal tangent. All right, the centers of two circles with radii 5 and 7 are 15 inches apart. So let's put 7 on the bigger circle for the radius and 5 on the smaller circle for the radius. And the centers are 15 units apart. So we just start our steps, draw a segment that connects the centers. That's 15. Okay. Let's see. The next step was to draw radii to the points of tangency on the same tangent. Those are already done. Same tangent. They touch that common internal tangent. Then again, through the center of the smaller circle, we are going to draw a segment that's parallel to the common tangent. There's your common tangent. Through the center of the smaller circle, up here, that's parallel. All right, now one of the things that happens with the common internal tangents is we have to see a rectangle and a right triangle. And I see part of a rectangle, but I don't see the whole thing. So I'm going to extend out this side over here. So I create this rectangle and this big right triangle. Mark those right angles. Okay, now the triangle that we want to use here is actually this big right triangle. All right, let's trace or copy that big right triangle down here. And we're going to transfer some measurements. This 15, that's on the hypotenuse. 15 here. And we want to find the length of the common internal tangent, which was this line that was right in here. I'm going to kind of squiggle over it. Is this one. That's what we're looking for. That's the X. That's the same length as this green one up here, which is a side. That's X up there. And then this side, we can figure that out because that was 5 here, which means that whole side is 12. Using Pythagorean theorem, or better yet, let's use the smaller inside numbers. We can divide out by a 3, which makes this a 5, and that a 4. Oh, nice. This is a 3, 4, 5 right triangle, which means this side here we divided by 3, so that makes that 9. So X, or that common internal tangent, is 9 inches. All right, I hope that helped. If you have problems, go back and watch this again and listen. Pause, do each step as I mention it. Thank you very much, and finish up section 11.1, day 1 homework.